Hello everyone. Welcome back to Civil Engineering Edge, your trusted channel for mastering engineering concepts. Today, we're diving into one of the most fundamental and powerful tools in structural analysis, the shear force and bending moment diagram, explained step by step, or SFD and BMD. We'll walk step by step through a real problem, find support reactions, construct the diagrams, and determine position and value the maximum bending moment. So let's get started. Problem statement. Display the beam diagram. Here's the beam we're working with. It's an 8-meter simply supported beam with a point load, a uniformly distributed load, UDL, and another point load. The goal is to draw the shear force and bending moment diagrams and mark the location and value of the maximum bending moment. Step 1. Calculate support reactions. Let's denote the support reactions as RA, left support, and RB, right support. We'll use static equilibrium to find these. Taking moment about point A, RB into 8 equals 5 into 2 plus 2 into 2 into 4 plus 2 divided 2 plus 10 into 6. RB equals 11.25 tons. RA plus RB equals 5 plus 2 into 2 plus 10 is equal to 19 tons. RA equals 19. 11.25 is equal to 7.75 tons. So RA equals 7.75 ton and RB equals 11.25 tons. Step 2. Construct the shear force diagram, SFD. Now we analyze the shear force of various sections. At B, right end shear force equals plus 11.25 ton. Just before point E, under 10 tons load, shear force equals 11.25. 10 equals plus 1.25 tons. At D, uniform distributed load and shear force equals 11.25. 10, 2 into 2 equals minus 2.75 tons. At C, before point load, 5 ton shear force equals minus 2.75 to 5 equals minus 7.75 tons. At A, left end shear force equals minus 7.75 plus 7.75 is equal to 0, satisfying equilibrium. Between E and D, shear force changes gradually due to uniform distributed load. It's a sloped line. 0 shear point, maximum bending moment location. Let the distance from D to this point be CD. 2.75 divided by 1.25 equals 2 CD divided by CD. Solving this, we get CD equals 0.625 meter. Step 3. Construct the bending moment diagram, BMD. Let's calculate the BM at key points now. At E, bending moment equals RB into 2 is equal to 11.25 into 2 is equal to 22.5 ton meter. At D, bending moment equals 11.25 into 4 to 10 into 2. 2 into 2 into 2 divided by 2 equals 21.00 ton meter. At C, bending moment equals 11.25 into 6 to 10 times 4. 2 into 2 into 2 plus 1 equals 15.5 ton meter. At the 0 shear point between D and E, bending moment maximum equals 11.25 into 2.625. 10 into 0.625. 2 into 0.625 into 0.625 divided by 2 equals 29.53. 6.25 to 0.39 equals 22.89 ton meter. So the maximum bending moment is 22.89 ton meter, located 0.625 meter from point D toward E. Diagram characteristics. Shear force diagram. Step at point loads, slope under uniform distributed load. Bending moment diagram. straight lines under point loads, parabolic curve under uniform distributed load. Bending moment diagram peaks where shear force is 0. That wraps up today's detailed explanation of how to draw shear force and bending moment diagrams. These tools are vital for safe and efficient structural design, and understanding them is a must for every civil engineer. If you found this helpful, don't forget to like, share, and subscribe to Civil Engineering Edge for more in-depth lessons like this. Drop your questions in the comments, and until next time, keep learning and keep building.